Hello. In this video, we're going to introduce a new operation on functions, and that's going to be called a composition. So the composition of functions is normally written as a small open circle, and what it does is it takes one function and puts it inside of another function. So, for example, if I have these two functions, f of x is x squared plus 1 and g of x is the square root of x plus 2. F of g of x is the same thing as taking g and putting it inside of x. So everywhere where I have this full g, I'll plug that into anywhere I see an x. So I get square root of x plus 2 squared plus 1. And so we can see the square root and squared cancel. And this gets me a brand new function, different than the others. Now, something that we have to take care about is the order that we do this in. So if I say g of f of x, that means I'm taking f and plugging it into g. So I'm taking this f, maybe I'll do this in a different color. I'm taking this f and plugging it in for g. So I get x squared plus 1 plus 2. And you can see here how we are actually getting different things. But that's not too surprising. We have other operations where we really have to be careful about the order. Right? It's very unlikely that when I'm subtracting two things, it's the same back and forth. And when I'm dividing two things, it's very unlikely that it's the same back and forth. Sometimes it is, like when f and g are the same number, then it doesn't matter which one I put on the top or the bottom. It doesn't matter which one I subtract from the other. But more often than not, this is going to hold. So composition of functions is not anything crazy. We do have to worry about the order, but that's not something that's novel. All right, let's try another example where there are multiple x's. I'm going to move this down a little bit. So this time we'll first try f of g of x. So we have our f, which is the cube root of x, and we're going to take this and plug it in. Not too bad. Now if we want to do the reverse, g of f of x, we're going to take this value and plug it in everywhere we see an x. So in this case we get the cube root of x plus 1 over the cube root of x. And again, you can see they kind of look similar, but they are not the same. So we do have to worry about the order. All right, so for our final one, we'll have a three-piece. We will do f of g of h. And that's how we would write this. Now, in order to figure this out, we're actually going to read from right to left. What we'll do is we'll think about h of x, and we'll put that inside of g. But then we'll think of g of this thing and put that inside of f. Alright, so let me go back to my h of x. So I'm taking h of x and I'm putting it inside of g. Everywhere I see an x and g, I'm going to put my h. So in this case, I get 1 over x plus 3. Now this time, I'm going to take this new function and plug it into the x's. So I get 1 over x plus 3 squared plus 1, which is the same thing as the top and the bottom squared. So really I could write it like this. But the important thing is making sure you're careful and you move in order. You're taking the rightmost one and you're plugging it in as you go. So you have this h and you're plugging it into x. You have this h of x and you're plugging it into g. And then you have this entire new function and you plug that into f. And we could do this as many times as we want. Normally we'll stick to 2 or 3. And that's everything we need to know about composing two functions.